Hi folks, welcome back to my channel. We're gonna have another Angular 3 video today, and in this video I'm gonna recreate this tutorial by Wawa Sensei on meshed portal material. Let's just take a look at the tutorial real quick of what we are building with Angular in Angular 3. Alright, so it looks like we're gonna have some portals, and in front of each portal we have a monster model and the background, which is the habitat of that monster. We can also kind of like interact with the portal to like enter or to go into the world of that monster, which is pretty cool. And this is a perfect use case for meshed portal material, which I just landed in Angular 3. So I was looking around for an example or like 3JS content, and I came across this tutorial by Wawa Sensei, which is perfect. All right, make sure that you watch this video by Wawa Sensei to understand the underlying 3JS techniques. Check out his courses if you like 3JS, or if you are into 3JS. Wawa is a great teacher in the 3JS ecosystem. So I'm gonna link all of the links mentioned in this video in the description down below. Okay, so as mentioned, we're gonna work with models, right, and textures, which are the backgrounds. And Wawa Sensei in his video, he mentions two sources. The first source is Quaternius, which is a 3D artist, and they provide there's like Ultimate Monsters pack, which is free. Awesome. So if you want to support the artist, support them through their Patreon, or go to their FAQ to find other ways to support this artist. So from the Ultimate Monsters pack, pick any 3, any 4 that you like. If you click on the download, you're going to be taken to a Google Drive, and from there you can just pick and download the GLTF files for your monsters. Next, for the textures, Wawa Sensei uses a service called a service from Blockade Labs. Now, and specifically, he uses the Skybox AI here. Now, if you sign up with Blockade Labs, you get like 15 generations for free, which should be enough for what we do here in this video. Make sure you pick your monsters first, so you can have enough information, enough context to generate the proper backgrounds for them. Okay, all right, so I'm gonna leave you to this task, and let's get started. So to start, we're gonna use a template repository from Angular 3, and again, I'm gonna link that URL, the template repository, in the description box down below. I'm gonna use the GitHub CLI to start now, but you can also go to the URL of the repo and use the GitHub web interface to have your repo ready. And this is the syntax if you use the GitHub CLI like me. And we're gonna use the template 2.12.0 specifically, because if you watch this video in the future, new version might come, things might break, so make sure to use the same version. Okay, I've already done that. I also already installed the node modules, so now I can just start with my IDE. Okay, so the template repository set up a couple of things. So it's set up like a very basic scene that you can get started right away, tailwind, right, and all of the dependencies and peer dependencies needed for this video. Okay, now with this, I'm gonna go back to, I'm gonna pop up the terminal, and I'm gonna run surf, and let's go here and go to this, and this is what we get. All right, okay, so now the next thing that I want to do, I want to grab the assets that I already picked out. So I'm gonna go open a finished project, and I'm gonna copy all of the assets from this project over to this project. So I'm gonna go to public, paste all of this in, and I'm gonna go back here and I'm gonna close this project down. So now we have this. I'm gonna remove all the transformed one, right? Okay, so I'm gonna use the Ghost Skull, the Mushroom King, and the Ninja models from the pack, and I'm using these three background for the monster. Okay. All right. So now with that in mind, let's get started. So the first thing is we want to adjust the camera a little bit. So I'm gonna say camera on the canvas. Let's say position is gonna be 0, 0, 10. So it's moved out a little bit, and the field of view of 30. Okay. Now back to the experience. I'm gonna remove this directive. All right. I'm gonna actually remove everything in here, just like that, and I'm gonna render a sphere which acts as the word, and that sphere is going to use the texture for the material. So for the mesh, we're going to do sphere geometry, and I'm going to extend everything from 3. Just make it easier for the purpose of the video to extend everything. And for the material, I'm going to use the standard material, right? And for the texture, I'm going to use protected texture, use inject texture from Soba, and I'm going to pick ghosttown.jpg. Okay, with that, I'm going to go back to material, assign the texture to the map property, and let's just see how it looks. Okay. Oh, so now we have the sphere, but it's all black because we're using standard material. And for standard material, we're gonna need some light, which I'm gonna do ambient light, and that is the intensity. I'm gonna do this. Why do I add the breakpoint here? All right. And for the environment, we're gonna do that. And I'm gonna save, go back, give it a little bit. Now we have the sphere. Now I want to be able to kind of like control the camera a little bit so that it can like spin around. So I'm gonna use GTS camera controls. So all of these are pre-made components from Angular 3 Soba, which is like a utility library accompanying Angular 3 to provide like easy to use, ready to use components like camera controls. I'm gonna save. I'm gonna go back. Now I should be able to spin around, right? So now we have the sphere with the texture, and you're looking at the outer layer of the text of the sphere. What we want is we want to render inside of the sphere. If you go inside of the sphere, right, everything is black. White, because we're not rendering the inside of the sphere. Now we only want to render the inside, so that when we go inside the sphere, it gives the impression that we are inside of the world. We look around and we see the texture, we see the inside of the sphere. So that's what I'm gonna do. So I'm gonna go back to the sphere, right? And for the side, we're gonna do back side, right? And I'm gonna save this, go back. It looks a little bit weird, right? But if you go inside of it, now we are inside of the sphere, and it gives the impression that this is the environment that we're working with, that we in, the world that we in, right? So there we go. Okay, so the next thing that I want to do is I want to change the parameters of the sphere so that it's bigger by default. So let's go back, and for that we're going to use the R's directive, and it's going to be like the radius of 5, and with 64 segments so they look rounded, more rounded. So go back, and now we are inside like by default, but if you zoom out you are outside, right? But we want this to be the default. Okay, cool. So now we have the background, We're gonna do that for one monster, and then we're gonna refactor and reuse it for the other monsters. So now I'm gonna go back to my IDE here. So what I want to do next is that I'm gonna use a CLI tool called Angular 3 GLTF to generate components using these models. Okay, and we're working with Ghost Skull, so let's generate that first. So I'm gonna go back to my terminal. I'm gonna do npx Angular 3 GLTF at latest. Okay, and for the first argument to the CLI tool is the path to your GLTF file. In this case, it's going to be publish and Ghost Skull GLTF. Next is the output. I'm going to pick Ghost Skull.ts file. This is where the component is going to be generated. For the selector, I'm going to use Ghost Skull, and for the name, it's going to be Ghost Skull. And let's just generate it. Cool. And now we have a transformed GLB, which lighter, right? Lighter than the original one. And we have a component. That's a bug with the generation, so I'm just gonna fix that real quick. And let's render this guy. Okay, go back here. I'm gonna go here. I'm gonna say app Ghost Skull. Right, and go back. Actually, let's pop up the terminal and run serve. So we go. Right, so now we have the model, the monster. But his position is a little bit off, right? We will scale him down a little bit and then bring him down on the y-axis so that he appears a little bit center. All right. So we're gonna do is options, scale 0.5, and position is gonna be -1 on the y-axis. Save that. Go back here. Perfect. Cool. Okay. Back to the model. Remember, this file is generated. All right. You don't write a lot of code in here, and most of the time, sometimes you leave them as is and use the model. Anyway. So the models from Quaternius comes with animations baked in, and the generation tool can also detect the animations in the models, and it will extract like the types of all the animations API correctly for you. So for this Ghost Skull model, we have some animation name, and I want to start with a default animation like a flying idol. Right, or some idle animation, and we're gonna use flying idle for this guy. Okay, so go down here, and we're gonna set up an effect. We say animations, this animations. If that is no, right, it can be undefined. Then we return, we stop the effect. If we do have the animations, we do actions dot. Look at that. All strongly typed flying idle. We're gonna reset. We're gonna do a little fade in, and we're gonna play so that the animation starts smoothly. And then we're gonna have some on cleanup here, and on cleanup we're gonna fade out from the animation. Okay. Now let's save this one. Go back. So now we have the little guy doing the flying animation. Cool beans. All right, now this is a good time to start working on the mesh portal material part. Okay, so remember, it's like for the mesh, for the portal material, for the portal, it looks like we have like some sort of window, like a plane, and then inside of that plane, we rendered basically this entire scene. We rendered that in the portal. And we're going to use the portal material to apply what we render in the portal, apply that as the material on the plane, on the plane object. So that's what we're going to do. That's the idea. Okay. So go back to experience. We're going to have a mesh and a plane. Oh, now instead of the plane, we can also use a routed box so that we have route corner. But because this is a box, so we have to give it some kind of depth. But we can also give it a tiny bit of depth, so it's very thin. It looks like a plane almost, but we have routed corners. So for the width, we're gonna go with 2, height is 3, and the depth is gonna be just 0.1. And now inside of here, we're gonna render out mesh portal material. Now for the content of the portal material, we have to use ng template so that the content of the portal material will be rendered on demand, basically. So the way that Angular renders work, is that everything in your template, if they are not behind any structural directive, any control flow, they will be rendered top to bottom synchronously. Now, if you have content projection, it's going to be projected after it has been rendered. Now, for portal, anything that has to do with portal in Angular 3, we have to do it in ng template so that the underlying mechanism of portal of Angular 3 can render that on demand in the specific place with the correct dependency injections. Okay, so we're going to use ng template for this one, and we're going to move everything in here. I'm going to save. Now let's go back. We have the routed box, okay, but everything is black because, again, everything we render inside of here is rendered to an off-screen scene, and that scene doesn't have the lighting needed to lit up the standard material or to lit up the model itself. So we're gonna move this inside, okay, and go back here. Now we have that effect, that kind of like the portal effect, and with just a simple component. This is very cool. All right. Now, so this is an opportunity to abstract this into a component. We can kind of see components in Angular 3 work exactly the way that you expect a component to work. So you can group things, and you can reuse things very organically, very idiomatic. So for this one, I'm going to create like a, I guess, like a environment.ts, which is just a component. I'm going to call this environment, right? It's going to be a component. Selector is going to be app environment. Standalone is going to be true. And for the template, I'm going to leave it there. And for schema, custom element schema, right? And chain detection and that. And I'll go back to experience. I'm going to just grab these two guys and paste it here. And of course, there's a math as well. Back to experience. This can be app environment. And this can be app environment. Save. Now we can remove this environment. Cool. Back to this. Everything works exactly the same way. Very cool, huh? Okay. Before we move on to the other monsters, we want to abstract a couple of things. We want to do a couple of things. First, we want to, because we're going to interact with this routed box, so we're going to make it look like that we're going to make some, like, we're going to add some indicator that this box is interactable. For example, we can change the cursor to like a pointer, like a bunt, right? When you hover over a bunt, the cursor changed to like a pointer cursor, so that the user knows that, oh, this is interactable. We can also change the animation of the model to a different animation on hover. Okay. Now the second thing is that we're gonna abstract the box, like the portal, into a component so that we can reuse for the other two monsters. So let's do that. Now for the hover interactions, we're gonna go to app skull. And we're gonna add a signal called hover and start with false. And on the group, we can listen for pointer over event. Okay, so Angular 3 has an event system that is very similar, with very similar syntax to what you're familiar with. Output syntax, like pointer over, click, double click, pointer out. And when these happen, we're going to update the hover signal accordingly. Okay, so now with that in mind, now we have the hover changing. So what we do, we need to change the cursor, right? We need to change the cursor to pointer on hover and back to default off hover. We want to also change the animation. Instead of flying idle, we want to change it to something else. Okay. So as you can kind of see that we need some more state, and we're gonna repeat this in the other two generated components later. So at this point, I'm gonna create a custom inject functions, which is a function that use inject in some way, some sort of like dependency injection API, and we're gonna make that a function that can be reused. Okay, if you're familiar with React hooks, they share a similar idea. And for this one, I'm gonna call this model hover animation, and it's gonna be a function inject model hover animation, and I'm gonna make a generic for animation API. This is gonna extend NGTS animation API and GTS animation clip. Now this function is gonna accept that a signal of Boolean, which we have, a signal of the animation API, which we also have from the model, right, from the generation of the model. And then we're gonna do a default animation name and the hover animation name. And the reason why we do a generic, so that we can, like, the default animation name and the hover animation name can be inferred correctly based on the GLTF model. Okay, first we need to change the cursor, right? So we have to inject the document. Okay, so now we have this. We have the hover signal, so we can also compute the animation name. And we have that. So if hover, we return the hover animation name. If not, we return the default animation name. Right, so with this, we now can do an effect. Okay, so if hover, the cursor is going to be pointer. If not, it's going to be default. And then we're going to update the style, or the cursor style on the document. That's the first effect. Now the second effect is I'm going to copy this effect from the model component, and I'm going to paste it here. Now for this, we're going to listen for the animation, which is animations APIs. Okay, for the actions, it's not going to be flying idle anymore. It's going to be different, and that is going to be the animation name. And with this, we're gonna do animation right here. Right, so now this is our custom inject function. We're gonna go back to Ghost Skull, and right here, I'm gonna call that inject model hover animation, passing hover, passing animation. Now we have the correct typing, right, from the animations. Default is gonna be flying idle, and on hover, let's do, I guess, like head, not that, but let's do like headbutt, right? And we can delete this effect entirely. Save that. Now go back to the app. Things still works, and if we hover, the animation change, the cursor change, right? There we go. And this is the custom inject function. All right, now back to experience. Now we are ready to abstract this into a custom component. So I'm gonna call this monster stage, right? Monster stage. It's gonna be a component selector, stand along. Oh, why? I guess angle 19, right? Schema, chain detection. Now for this one, I'm gonna go back to experience. I'm gonna copy this entire thing back to monster stage, grab this in a group and paste that in. Backside still the same. Now for the texture, right? We don't know what texture from the monster stage component we're gonna render. So we're gonna accept an input for the path to the texture, and then from that path, from the signal input, we're gonna make our texture. Okay, so now for the texture path, it's gonna be an input require of string. From that, we now have the texture, which works really nice with signals, right? So inject texture, pass in that signal directly. Now we have the texture. Okay, now for the model, we're not gonna render the model here, but we're gonna use content projection to do that. So now I'm gonna go back to the experience. Everything is actually, we're gonna do in app monster stage. Inside of here is gonna be this ghost skull, and the texture path is gonna be that ghost town JPEG. And remove that, and we can remove this. We can remove all of this, and also the side, also the texture. Done. Back to here. Everything still works correctly. Okay, so now we're ready to do the other two monsters. So I'm gonna pop up my terminal, stop this, do this, do this for the other two, which is Mushroom King, and this is what Mushroom King, and Mushroom King. I'm gonna do the same for Ninja. Okay, let's restart. Let's close. So now we have Ninja Mushroom King component. Unfortunately, we're gonna have to do the same thing here. We're gonna repeat this process here for Mushroom King and Ninja, which is the hovered and this inject model hover animation. So I'm gonna go there. I'm gonna do protect hover. Right back here is gonna be that. Back down here, remove this one, and I'm gonna do inject model hover. And for this one, I'm gonna use I guess wave as the hover animation. Do the same thing for Ninja. Protect it, hover. Do this back to the group. Pointer over, pointer out, back down, and inject model hover animation. Same thing here. There's a wave as well, so I'm going to use the wave for the Ninja as well. Now we're going to go back to experience. We're going to just duplicate this 2 times. For the texture path on this guy, we're going to do ghost, not ghost town, but mushroom forest. For this one, it's going to be Ninja Town. Okay. Now for this, it's going to be Mushroom King component. And for this, it's going to be Ninja component. Save. Now we're going to see only one because they are on top of each other. So let's adjust the monster stage to accept position and rotation. So for position, it's gonna be this, and for rotation, it's gonna be this. And we're gonna pass that to the group. Save. Go back to experience. For the ghost skull, we're gonna move it back a little bit. For the Mushroom King, we're gonna move it to the left and turn it a little bit. And for the Ninja, we're gonna move it to the right, basically the opposite of the Mushroom King. So let's save and go back, and now we have the 3 monsters, and they are all work. All right. So now, what we can do is from Wobble Sensei video, he adds some text for the monster as well, right? So some text, we can do that with ngts text component. So here we can do ngts text component, but I'm not going to do that because I think it's not supporting the purpose of this video. If you want to add the text, watch Waba Sensei video for some idea and go back here and implement it with ngts text component. Okay, so now what we want to do is we want to add that interaction of double click, and then we're going to go inside of the portal word. And how it works, how we're going to do that is that on the mesh portal material, there's a property called plan. When plan is 0, Angular 3 is going to render the root scene, right? When plan is 1, the Angular 3 is going to render the portal scene. So let's show that. I'm going to go to my options here. I'm going to do plan 1. And you can see that it renders the scene of the ninja because it is the last one, right? It's the last item rendered on the template. All right, so we're going to do that by attaching a double click event here. And when we double click on the routed box, we're going to set an active signal. We're going to basically toggle the active signal. To do that, we're going to add the active signal here. So now we have the active thing. We can change the plane, right? Which we can do. So if I do this option, I do plan active, yeah, that. You can see that it's kind of like jumpy. So go back here. I double click. You can see that now we're inside of this word. Go out, go in, go out, go in, right? We need some kind of like transition, so it's kind of like goes in smoothly, entering, you know. To do that, we're not gonna buy the options directly, but instead we're gonna do an animation loop, and in that animation loop, we're gonna ease into the correct value. So from 0, we're gonna ease into 1 with some like Bezier curve or like some timing function, and from 1 we're going to ease back to 0. So that's what we're going to do. So right, let's grab the reference to the portal material. We're going to use view child, and because the portal material is not under any influence of any structural directive, any ng template, any control flow, we're going to do required it, right? Because it's kind of like static. Right, so now with that, we're going to set up a constructor. Inside of this constructor, we're going to do inject before render, which is a way to participate in the render loop, animation loop. And here we have the delta. So here we have that, right? So we have is active or not. And then we have access to the material, the underlying material of the portal material ref. Okay, now we're going to use easing, which is from math library. And here we use dam. We want to do what? We're going to change the property called plan on the material. We change it from 1 to 0, and we pass in the delta. And we have the smooth time of 0.2. So basically in 0.2 seconds. It's going to go from 1 to 0, 0 to 1 in 0.2 seconds. All right. So now with this, I'm going to go back. And I'm going to double click here. Now it's transitioning nicely. Right. With some kind of like ease timing function. Cool. Next is we're going to deal with the camera. So when we inside of the Mushroom King camera, we want to point or look at the mushroom, right? So to do this, we have the camera controls, so we can grab that camera controls and set the look at position at the that box, right? That we click. So to do that, we're going to go back to our experience component. And on the camera controls, we're going to pass in make default true. Okay, so this means that, hey, camera controls, you are now the default controls for the canvas, for the entire canvas, which means that in my monster stage component, I can grab a hold of that controls using dependency injection. So we have inject store from Angular 3. On the store, we have the controls, which is a signal of the camera controls from the camera controls library, because NGTS camera controls wraps this and it's going to expose this as the instance, controls instance. So now we have this. The next thing is we want to be able to grab the position of the box. So we're going to grab the ref of the box as well. Okay, so now in here we set up an effect. We have, yeah, all of this information. We have the is active or not, rounded box, or controls. The way that I do this is that I track the dependencies for this effect inside of an array so that I know what I'm tracking when I get into the effect function. All right, so if I'm active, I'm going to set up a target position, which is a brand new vector. I'm going to grab the box, I'm going to get the world position of that and pass this in, so that target position is going to take the world position of the box. And now I'm going to use the control to set the look at this position of the camera. So zoom in a little bit. We go from 10, right? The default is 10. We go from 10 to 5, and we pass in the target when we active. Else we go back out to the default position. Okay, so now this is the effect for controlling the camera. So I'm gonna go back here. Now we go inside here, go inside here, and we go inside here. All right, so I think that's it. That's the main idea, and then that is the project that Wawa Sensei kind of like goes over in his tutorial. He has a couple of nice things, like you cannot move the camera up and down more than you should be able to, but I'm not gonna do that in this thing, in my recreation, because I think it's not very relevant to the things I want to talk about, which is the mesh portal material. Right, so that's pretty much it. So let's look at these things. So we have app environment, which is to show that component with Angular 3 works exactly like how you expect like a regular Angular application component to work. You can abstract things, group things together, and then reuse it. So we reuse the app environment here and inside of the monster stage. All right. We learned that Angular 3 Soba is a collection of components, pre-made components, ready-to-use components like routed box, mesh portal material. We learned that we have an event system with double-click, familiar syntax with output syntax, right? And anything else? We have Angular 3 GLTF, which is a CLI tool to generate these components. Then you can just drop in and use on your template without having to worry about setting up like the animations, setting up transforms, setting up like this syntax, right? It's this template to be able to use the GLTF the right way. So we have all of that in Angular 3 ecosystem. And we learned that we can have like a custom inject function that does things nicely. This can also be a directive if you like, right? And that directive is going to accept these exact same thing. But I like a function because why not, right? Last but not least, anything else that we want to cover here? One last thing is that you can see that everything in my components, all of my components basically, are signals. So everything is driven by signals. The APIs that Angular 3 kind of like expose or all signals. So we have like this texture as a signal. We have this kind of like animations is signals right around here. Oh, this is not a signals, but it has ready as a signal. So when it is ready, yeah, everything is a signals driven by signals, and that's how it works. Okay, thank you, and I'll see you guys in the next video.